In question 7, a tool for putting fences posts into the ground is called a post hammer. The distance in millimeter that the post sinks into the ground on each impact of the post hammer follows a geometric progression. The first three impact causes the post to sink into the ground by 50, 40, and 32 millimeters respectively. In part A, we have to verify that the ninth impact is the first in which the post sinks less than 10 millimeters into the ground. Now, as it is a geometric progression, the nth term for a geometric progression is given by a r to the power n minus 1. As a is 50 over here, and to find r, we divide two consecutive terms. So r will be the second term divided by the first term, which will be equals to 4 upon 5. So the nth term formula will be equals to, as the first term is 50, so 50 into 4 upon 5 to the power n minus 1. As we have to verify for the ninth impact, it means we are finding the ninth term. So this will become n9 is equals to 50 into 4 upon 5 into 9 minus 1. So this will become 50 into 4 upon 5 to the power 8. Substituting this value into the calculator, this will come out to be 8.39. So basically, we wanted to verify that this is the ninth impact is the first in which the post sinks less than 10 millimeters into the ground. So this is less than 10. However, just to verify, let's first find the eighth term. So the eighth term should be greater than 8.39. So for the eighth term, we will write 50 into 4 upon 5 into 8 minus 1. So this will become, the eighth term will be 50 into 4 upon 5 to the power 7. Substituting this in the calculator, we will get this value as 10.5. As this is greater than 10, it means that the ninth term is the first in which the post will sink less than 10 millimeters. In part B, we have to find the total depth of the post in the ground after 20 impacts. So as it is talking about the total depth, it means we'll have to apply the sum formula, which is a into 1 minus r to the power n upon 1 minus r. In this case, a is 50, so this will be 50 into 1 minus 0.8. R was 4 upon 5, which is 0.8. And as we are finding for the 20 impacts, so this will be 20 divided by 1 minus 0.8. Substituting this in the calculator, the sum for the total depth after 20 impacts will be equals to 247. In part C, it is asking us to find the greatest total depth in the ground which could theoretically be achieved. Now, as in this progression, r is less than 1, and it is talking about the greatest total depth, it means, for example, if we have n as, let's say, if we keep on increasing the value of to 10, 100, 1,000, and so on, what could be the greatest total depth? It means we are talking about the sum to infinity. Now, the sum to infinity formula is a upon 1 minus r. And if you look at the sum formula, which is a into 1 minus r to the power n divided by 1 minus r, as r is 0.8, as we keep on increasing the power, this number will keep on decreasing. And for a very high value of n, this will nearly be 0. So that's why it will be taken as a upon 1 minus r. Now, a is 50. We'll divide it by 1 minus 0.8. So 50 divided by 0.2 will be equals to 250. So 250 millimeters is the greatest depth in the ground which could theoretically be achieved.